You made it. This is the final lesson of their February break assignment. We're going to bring everything together. So we've done simplifying radicals, rational, irrational, multiplying, dividing, and now we're going to get to adding and subtracting. Adding and subtracting is the most basic operation, and we have to be very, very careful when we're adding and subtracting square roots. So you're going to treat this almost exactly like you would treat variables. So if I had 3 x's here in part A and I added 5 x's to it, all together there would be 8 x's. Well, radicals, let's look down here, are very similar. This is saying I've got 3 radical 2's, and I'm going to add 5 more radical 2's to it. So that means altogether I will have 8 radical 2's. Let's try the next one, B. 8y's minus 2y's gives me 6y's. So 8 radical 5's minus 2 of those radical 5's will give me 6 radical 5's. 9t plus 2t, that's 11t, minus 6t will give me 5t's. I can do the same thing with radicals. 9 radical 3's plus 2 radical 3's will give me 11 radical 3's. And then I can subtract 6 radical 3's. If I have 11 radical 3's minus 6 radical 3's, I will be left with 5 radical 3's. Number one mistake students make is, like for part D, they might say it's 8 radical 4. Well, there are no radical 4's up here. I've got 3 radical 2's that are sitting here. And then I'm going to add to it 5 more radical 2's. So there are no radical 4's here. I just have a bunch of radical 2's, and how many do I have? I've got 8. Since we can only add and subtract quantities with square roots that have the same radicand, that's the number under the radical, we need to sometimes simplify them before we know if they're the same or not. So in part A, these radicands are not the same. However, square root of 8 can be simplified. 8 can break down into 4 and 2. 4 can break into 2 and 2. So this becomes the square root of 2 squared times the square root of 2, and that is 2 radical 2. So I can rewrite this as 2 radical 2's plus 5 more radical 2's. Altogether, that gives me 7 radical 2's. B. My radicands are different. However, the perfect square of 9 can go into 27. So I actually think this can be broken down. 9 will break into 3 times 3. Again, square roots and squares undo each other. So I've got the square root of 3 squared times the square root of 3. That takes care of all 3 of those factors. And this becomes 3 radical 3. So here's where I've got to be careful. There's a 2 hanging out front here. So this becomes 2 times this quantity that radical 27 reduced down to. I can multiply things that are outside the radicals. So this becomes 6 radical 3 minus 1 radical 3. So if you have 6 radical 3's on the table, 1 gets taken away. You are now only going to have 5 radical 3's left. Okay, part C. None of those radicands are the same. However, I know the perfect square of 4 can go into 20. So this becomes the square root of 2 squared times the square root of 5. So 2 radical 5. So square root of 20 can be rewritten as 2 radical 5 plus 9 radical 5 can't be reduced. 5 can't be broken down into any other perfect squares. And then 45. 9 is a perfect square that goes into 45. 9 breaks down into 3 and 3. So this becomes the square root of 3 squared times square root of 5. That's 3 radical 5. So I've got 2 radical 5s and 9 radical 5s. That's 11 radical 5s minus 3 radical 5s. 11, 10, 9, 8. 8 radical 5. And that is it for our lessons. Now, the last thing I want to cover with you is at the very bottom of your notes packet, it says this right down here. So there's practice for lesson 5. And then there is one more Delta Math assignment, and it's a practice test on all of the things I've asked you to do over the break. After you are finished with the practice test, you can see your score, and there's a corrections assignment that you can do. When you return from February break, there will be an exam on this mini unit. So you want to make sure you know how to do all these types of problems, okay? Other than that, we are all set. Thanks so much.